Hello everyone, welcome to Algebra 2 Notes 1.2. We're looking at types of real numbers here today. Real numbers are pretty essential to understand some of the core mechanics they have. So real numbers are any number that exists on a number line. It can be from negative infinity all the way up to positive infinity. Most common you'll see is 0, right in the dead center of most number lines. But you can go negative, you can go negative 100, you can go negative 50, go negative 1. This is definitely not to scale. You can go 1, 2, 3. A pi would be on here just a little bit past 3 at 3.14. And even more specific than that, if you know anything about pi, you know that it stretches off into an infinity. And a number of digits at least. So that's a good example of an irrational number. We'll get to more of that later. Anything that can be placed on a numbered line is real. One of the go-to examples of a non-real number that you can't place on a number line, but does have some mathematical application, we're not going to get into it for this, but would be the square root of negative 1. Really any negative number, because the square root is just the number of what you're looking at here, that when multiplied by itself gets you that number. And we can't get a negative number by multiplying one number by itself. Because if we have a negative number, say negative 2 squared, that's going to give us 4, a positive number, because the negative times a negative gives us a positive. And if we have 2 squared, well, that's going to give us 4 as well. So there's no real number that when multiplied by itself gets you a negative. So that's a good example that negative 1, square root of negative 1 at least, is a good example of an imaginary number. We're not going to get into that too detailed though, so don't get hung up on that. We're just looking at real numbers today. So the most specific type of number that you can have would be a natural number right here. Those are numbers that can be written without a fraction or decimal. Without is the key word here. Without a fraction or decimal that is greater than or equal to 1. Now, a natural number is also a whole number. This one right here. It is also an integer. Right here. It's rational. Right here. And it is definitely real. Right here. So as you go very specific, you're going to find that an integer is always going to be a rational, and a rational is always real. And a whole is always an integer, which makes it always rational, which makes it always real. That's a pretty important concept because we can get a little bit caught up in the weeds and say, oh, it's a whole number, that's it, it's nothing else. That's not true. Whole numbers are always real, they're always integers, they're always rational. You don't need to say it in any specific order, but you do need to understand that as we lose detail, as we zoom out further and further and start to incorporate more numbers, that doesn't make a number not an integer if it's whole. That'll make more sense as we're going on if that's a little confusing. So let's jump on to the next one. Oh, first, a good example of why do you need to know this? Why do you need to know what a natural number is? It's good for only taking in numbers that matter. So if I asked dog owners, how many dogs do you have? Their answer is going to be a whole number, and it's going to be a whole number that's greater than or equal to 1. You're not going to have a dog owner say 0, I don't have any dogs, because then they wouldn't be a dog owner. You will only have someone say, oh, I have 1 dog, or I have 4 dogs, or I have 3. You might have someone trying to be funny and say, oh, I have 1.5 dogs, because one of my dog acts more like a cat than a dog, but really they have 2 dogs. Whole numbers, we'll jump into. Again, well, first off, numbers that can be written without a fraction or a decimal that is greater than or equal to 0. So whole numbers, also integer, also rational, and also real. It's really important to remember that whole numbers, as we go very specific, they fall into those broader definitions as well. A good example of a whole number is, how many pets do you have? No one can own negative pets, but there are plenty of people out there that don't own any, and that would be 0. I don't have any pets. But again, you can't have half of a pet or 3/4 of a dog. You're going to have a whole number of pets. The next category here would be integers. So numbers that can be written without, again, that's very important to remember with all of these. Natural, whole, and integers have to be written without a fraction or a decimal. But integers are the most broad of these whole type numbers, this written without a fraction or a decimal, because they can be positive, they can be negative, or they can be 0. So an integer is also a rational number, and it is a real number. There's a definite pattern there. I'm sure that most of you have noticed that we're following the same pattern. A good example of an integer is a song's position on a music chart. It may move 3 spaces up, or it may move 4 spaces down, or -4 spaces up. That's usually how they denote that. If a chart, you see a song with its position equal -4, that means that it may have fallen from the first place spot down to the 5th. A good example of an integer there. The loosest definition of real numbers, one of two really, is a rational number. So these are numbers that can be written as fractions. In decimal form, they can either repeat or end. So a good example of a rational number that has a decimal that does just end would be 2/5. That's going to equal 0.4. A good example of a rational number that does not end and will repeat forever is, we'll just say, 2/3. Typically that's written as 0.6667 ... They round up on that very last digit here. But if we keep on going on for infinity, we'd run out of paper. It would just keep going until we run out of space. Rational numbers are also real. Very important to remember. So just like we discussed a little bit lower here, real numbers are numbers that can be put on a number line. Oh, let me jump back. A good example of a rational number here would be temperature. It would be height from sea level in feet, because you could be, most of the time, they'll just say, oh, I'm, 400 feet above sea level. But really, I would be very stunned if someone was exactly 400 feet. They're probably 400.273, or it could carry on and on and on. It's going to be more specific than a integer, is my point there. So a good example of a rational number is something that can be measured specifically, and it does have a definite value, but can be between those whole numbers. So back to real numbers. So numbers that can be put on a number line, they must be either rational or irrational. So if you find yourself in a situation where you say, oh, this is a real number, but it's not rational or irrational, you might want to take a second look. They have to be rational or they have to be irrational. Now, if a number is rational, that means that it is not irrational. And if a number is irrational, that means that it is not rational. You cannot be both rational and irrational. So let's find out what the specific definition for irrational numbers are. Numbers that cannot be written as fractions of integers. In decimal form, they never repeat or never end. An irrational number is also a real number. So good examples of irrational numbers would be the square root of 2, it would be pi. These are numbers that never end, and they do not repeat. There's no pattern to them so far as what we can determine yet. Um, they'll stretch on forever and ever. 3.14, I'm sure you've seen the papers that some math teachers have wrap around their room where it just keeps on going and going and going. There's actually some pretty interesting software out there that you can use to try and find specific sequences of numbers. Um, you can find almost any 5-digit number, I believe, in the first million digits of pi. It goes on for that long. And there are programs that can find up to the first 2 billion digits of pi. I think they're out there. They're pretty interesting, I think, but I am a math nerd, so do with that what you will. Um, Now, just to touch on imaginary numbers again, they're numbers that cannot be plotted on a number line, just like we wrote in for real numbers. We're looking for number line here. They technically exist, but you can't assign them a normal value. So you'll learn more about those next semester, I'm sure. But again, that's square root of negative numbers is the easiest example. We don't really need to jump more in depth with that. And that is types of real numbers. We're going to get lots of practice with this. It will become much more familiar to you as we jump through these, and you'll be able to recognize what category these numbers that we deal with fall into pretty quick as the semester grows on. See you next time.